Hello, I'm John Gastineau, staff scientist and physicist with Vernier Software and Technology. I'm going to tell you about the Vernier radiation monitor. It's a Geiger tube that connects to any of our interfaces that accept a digital sensor. I'm going to use it here with a LabQuest 2. I'll plug it into a digital port, and you can see that the LabQuest detects the presence of the radiation monitor and displays counts. The counts represent a cumulative display of the events recorded by the radiation monitor. I have some Fiestaware stoneware made before World War II. The orange glaze is made from uranium dioxide. Since this is pre-World War II, the uranium is natural and includes a certain fraction of the radioactive isotope. Radioactive uranium is a gamma emitter. Now, if I separate my radiation monitor and the plate, you see that so I've gotten 135 counts so far, and it increases slowly just based on background radiation. But if I bring the radiation monitor up to the plate, you see the count rate increase dramatically. I have several other radioactive sources here. Let's first use an alpha source made out of polonium-210. Alpha rays are just helium nuclei that are massive, they're charged, so they don't penetrate very well. If I put my radiation counter right on top of the source, you can see the numbers increasing, indicating that the radiation monitor is detecting nuclear disintegrations. If I put even a piece of paper in there, you see that the counts stop increasing so rapidly. So even a few sheets of paper is enough to block alpha radiation. Beta rays are a bit different. So I'm going to take a beta source. This is strontium-90. And if you look at the count, you see it increasing slowly. That's just the background. If I put it right on top of the source, the numbers accumulate rapidly. Let me take that same piece of paper and put it in, and you see that the counts continue to accumulate rapidly, showing that the beta rays get right through the paper. On the other hand, if I take a sheet of aluminum and put that between my source and the counter, you see that the counts stop accumulating so quickly, indicating that the beta rays are getting blocked by only about 1 millimeter of aluminum. My last source is a gamma source. This is cobalt-60. Gamma rays are photons. They're the most penetrating of all. Here you see a slow accumulation of counts. So that's just the background. I'll put the sensor right next to the gamma source, and the counts accumulate rapidly. For this one, I can put my aluminum sheet in there, and the counts continue to accumulate, showing that most of the gammas still get right through this 1 millimeter aluminum plate. So that's the Vernier radiation monitor. For more information on this, go to the Vernier website.